All right, guys, today we're going to talk about powers and exponents. Woo! So again, remember, anything that you see already on the typey, remember, you righty. Perfect. All right, Yogi decided to start saving money by putting a penny in his piggy bank and then doubling the amount he saves each week. Question number 1, how much will he have in 8 weeks? Well, handy dandy writing utensil. First week, he puts in a penny. So that's 0.01. Means he has 0.01 or a penny in there. Whoa! Week number 2, he puts in 2 pennies. Okay, so he puts in 2 pennies, already had 1, so now he has a grand total of 3 pennies. Next, he puts in 4 pennies, because remember, we're doubling every time, doubling the amount. Well, he already had 3 plus 4 gives him a solid 7 pennies. Next, we get double of 4, is 8. So we put in a whopping 8 pennies. 8 and 7 will give me 15. Then we double that 8 and we get 16 cents. Woot, woot. 16 and 15 give me 31. We're going to double that 16 and we're going to get 32 cents. 32 and 31 gives me 63, and I can write the correct number. 32 times 2, or 32 plus 2 is 64. 64 and 63 gives me $1.27. 64 times 2 is $1.28. That $1.28 plus $1.27 gives me $2.55. Oh, $1.28 gives me $2.56. And then $2.56 and $2.55 gives me $5.11. Yeah. So by the end of week 8, he should have $5.11. All right, some questions I want to ask about this before moving on. How many 2s do we multiply together by week 4? Okay, so here's week 4. 1, 2, 3, 4. So we multiplied 4 2s together. Okay, what about week 5? Well, okay, the reason I'm not starting here is how many 2s? There's no 2s in there, is there? Nope. So that's why we started 1. So to get to 5, we did 1, 2, 3, 4, 5. How much money will he save in week 8? $2.56. Continue the table to find out when he'll save enough money to buy $80 pair of shoes. And I need to hit the Extendo Pageo button. All right, so 256 times 2, 5, 12. So 512 and 511 is 1023. I'm pushing buttons, oh no. Okay, and then we double that, and that gives me 1024. Oof, that 0 is rough. I don't want to erase my... So that gives me 2047. If I double that, that gives me 2048. And that gives me 4095. If I double this, it gives me 40, wait, that's gonna give me 4096, and that'll give me 8191. So it's gonna take him 12 whole weeks to save $80 to get some shoes. All right, why do we care about that? What does that have anything to do with what we're going to talk about today? Well, it kind of, those middle questions are what kind of lead me into what we're talking about. All right. Okay, a product of repeated factors can be expressed as a power, that is, using it as an exponent and a base. So, for example, when I asked how many 2's did we multiply together in week 4, 2 times 2 times 2 times 2, there are 4 2's, or 4 factors of 2. It has a base of 2, and it's called the common base. And the exponent, in this case 4, tells how many times the base is used to multiply together. Okay, what do they look like and sound like? And I want to do this. All right, when I see the word power, words and factors. So 3 with an exponent of 1, notice how it's kind of up there. It's not just like right next to, it's not the same size, it's a little bit smaller. In the upper quadrant, kind of up there. We say that's 3 to the first power, and the factor is just a single 3. So 3 just by itself. 3 seconds, or 3 squared, is 3 times 3. 3 with the 3 is 3 to the third, or 3 cubed. 3 3's being multiplied. 3 to the fourth, or 3 to the fourth, or just 3 to the fourth power. So 4 of them. And that continues going on and on and on and on and on until the nth power, meaning some kind of random number. So this goes on until you want n to be 100 or 1,000 or whatever number you want it to be. That's how you do exponents. Now, what we're going to do is we're going to work on simplifying that. So first, sorry, my notebook's in the way. I'm going to have, in parentheses, -2 and a 3. Now, I don't need this. Okay, this is where we get in the question. This is where I kind of like get, how do I want to say this? Because it's got a negative, I always want to put numbers with negatives in parentheses. However, since the 3 does not have a negative, we're just going to write 3. I have 1, 2, 3 factors of -2. So it's -2 to the third power times 1, 2, 3, 4, 3 to the fourth power. Okay. Notice how my 2's are together and my 3's are together. But what do you notice about the next one? I've got an A here and an A here. Well, it doesn't matter where they're at as long as they're all multiplied together. We know, this is just an example. Example. I can take the number 3 times the number 4, and my answer is 12. I can also take 4 times 3, and my answer is still 12. Even though I moved my numbers around, my answer stayed the same. So as long as you're multiplying, you can do what's called the commutative property. You can move everyone around, and it doesn't change the problem. So I have A, I'm really bad at lowercase a's. I'm sorry if it looks like a 9. To the second times B to the 1, 2, 3. All right, I have 1, 2, 3, 4. I don't know why it's in that. So I have 1/2 to the fourth. And you're like, but wait a minute, hold up. You didn't put any of these others in parentheses. You only put the 2 in parentheses because it was negative. Since I have a fraction, we'll go more into detail on this in a few videos. If I have fractions, it's going to both pieces of it. So it's going to the top and the bottom. So it's got more than one technical term, kind of. I have to put it in a parentheses. I have 4 to the 1, 2, 3, and 5 squared. Ooh, everyone hates me with this. Okay, I have m to the 1, 2, 3 times n to the second. Next idea, evaluate. That is to determine the amount of something, usually an expression. So it wants me to evaluate -2/3 to the 4th power. So what we're going to do is I'm going to write it out. And those are negative signs. Sometimes it's not the easiest to get what I want to look like perfectly pretty. Again, I'm writing with my finger. It's not the best. And I'm going to multiply the first two together. So when I multiply fractions, top times top, bottom times bottom. So the negatives, remember, go associated with the top number. So -2 times -2 is 4. 3 times 3 is 9. And I'm going to take that times -2 to the third. Again, top times top, bottom times bottom. And I need to write a little bit smaller. So remember, 4/9. Top times top gives me -8. Bottom times bottom gives me 27. And then I use this guy. And next I need to do the last one. So top times top, which is +16. Bottom times bottom. Oh, 27 times 3. 3 times 7 is 21. 3 times 2 is 6. Plus 2 more is 8. So 81. So I have evaluated that example to be 16/81. Try this one. Right? Yeah, try this one. Pause the video, try it. See what you get. See if you agree with me. It's a big number. 256. Oh yeah. Okay, let's try another one together. How much space do I have? Not the best. Okay. So I have -2 times -2 times -2 times -2 times -2. What is that? 1, 2, 3, 4, 5. -2. 6 times. -2 times -2 gives me 4. Times -2, which is that guy. Gives me -8. Times -2, which is this guy. Gives me 16. Times -2, which is this one. Which is -32. Times -2. So times, which is this guy. And that is 64. I have 1/5 times 1/5 times 1/5. So top times top, bottom times bottom, top times top, bottom times bottom. Top times 5 is 25. 5 times 2 is 10, plus 2 more is 12. Wow, word problem. The deck of a skateboard has an area of about 2 to the 5th times 7 square inches. What's the area? So essentially, it's telling me this is the formula for the area, and it wants to know what it is. So I'm just going to evaluate it. So I have 2 to the 5th. So times 7. And I'm going to, oh, golly, it doesn't really matter. I'm going to go left, right. We're going to do PEMDAS. So 2 times 2 is 4. Times 2, which is this one, is 8. Times 2, which is this one, is 16. That's not very straight. times 2 more, which is this one, is 32. And then I have to take 32 times 7, and I don't know that off the top of my head. So 32 times 7, 7 times 2 is 14, 21, 22. So the area of the skateboard is 224 inches squared. Or square inches, same thing. Go ahead and try this one. Tell me what you come up with. Same idea as the one above. Just a little bit more to it. You can do it. I have faith in you. Pause the video. Four thousand two hundred foot squared, excuse me. Yep. All right. Next one. If A is equal to 3 and B equals 5, then evaluate the following. So this is the part that I think is kind of cool. This is one of the things that I like about algebra, because I'm weird, is that I know that I have to write this strategically or it's not going to work. That's not what I want to do. Probably like, why are you writing it so weird? I don't want that to be green. So it's telling me that every time I see an A, I see the value of 3. So instead of A, I'm going to put a 3. Now I get the color scheme. Every time I see a B, I'm going to pretend it's a 5. Oh, I wrote that too quick. So every time I see a B, I'm going to turn it into a 5. I know you can't do that under your notes, so I'm going to rewrite it again. I wanted to show you that visual, but I'm going to write it again so you can follow through. So every time I see an A, I'm going to write a 3. So I have 3 squared plus every time I see FB, I'm going to write a 5. So 5 to the 4th. It's going to be a big number. Just throwing that out there now. So 3 squared is 3 times 3. I'm putting parentheses for my order of operations. 5 to the 4th is 1, 2, 3, 4 of them multiplied together. This first part's kind of easy. 3 times 3 is 9. However, this part's going to take a little bit of work. So 5 times 5 is 25. 25 times 5 we did earlier, which was 125. And then 125 times 5, I do not know off the top of my head. So 25 and 12, 6. So 9 plus 6, 25, which would be 635, so 634. All right, this one's a little bit easier. Pause video, you do it. Now you're probably like, wait a minute, I didn't get that. How on earth did she get that? Usually I don't go back and do these, but these are a little bit complex. So I'm going to go ahead and show you how to do it. So I have 3 minus 5 quantity squared. My order of operations, so may I simplify inside the parentheses first. So 3 minus 5 is 2, specifically negative 2, excuse me. And then I have negative 2, ooh, that was real quick. Then I have negative 2 times negative 2, which is a positive 4. That's how that one's for. All right, this is very similar to the first one I did, so I want you to pause this one and see what you get to. Oh. Did you get 17? Let me know if you don't get 17. Have a chit chat with me. Next one's a little bit easier. So if I have a C, C is -4, plus D, which is 9, to the third power. -4 plus 9 gives me 5. 5 cubed is 5 times 5 times 5. So 25 times 5, which is 125. We've done that a few times now. We kind of should start picking up on that one. This one's a little bit more complex, but we can do it. So I have D cubed, so 9 cubed, minus parenthesis -4 squared minus 2. You're probably like, whoa, 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 whoa. Why did she put this in the parentheses? What's going on? Remember when I started way back here? Negatives have parentheses around it always. 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 Oops, too far. Sorry about that, guys. So we need to work on the innermost sets of, well, we're just going to expand it out. So 9 to the third is 9 times 9 times 9 minus -4 times -4 minus 2. And I do the brackets so you can kind of see the innermost guy, because after a while, parentheses inside of parentheses inside of parentheses are kind of scary to look at. We'll work on the outside first. So 9 times 9 is 81. And then 81 times 9. 9 times 1 is 9. 9 times 8 is 72. Minus -4 times -4 is positive 16. Positive 16 minus 2 is 14. And notice how this negative sign keeps dropping through. It's been following along the entire time. And then 729 minus 14 is 715. All right, guys, hope you had a good lesson.